Welcome to Maths with Bob. Today we're looking at a superannuation problem where not only does the investment earn interest, but it's actually being incremented as it goes through time as well. So we've got an interesting situation here. So the first thing, always draw up a timeline. So you always, for any superannuation problem, doesn't matter how complicated it is, draw up a timeline. Always just put a start here, mark a few years. 1, 2, say 3, ... Obviously over here is 20, and one before is 19. Okay, so we are investing for 20 years, and sometimes underneath I like to just write, this is the end of year 1 and the beginning, say, of year 2, end of year 2, beginning 3, I just rewrite, just to remind myself, this is the end of year 19, at the beginning of the 20th year, really, and here we have the end of the 20th year, right down the end here. Okay, sometimes this helps because if we were putting it at the beginning or the end of the year, we can just sort of adjust it accordingly. So, the first $1,000, we're putting it at the start, at the beginning. Now this is actually, you can see here, this is the beginning of 1, here, right at the front here. Beginning of year 1. So, $1,000. Okay. Now, it is going to fly through time for 20 years. So let's so this would go right through for 20 years. Okay. The next $1,000 will only go through for 19 years, etc. Okay. So the first thing is, let's have a look at it from this, not before it increases. So I'm going to say, well, this one is getting 1.12. The pen's not working quite well here. I see we're using the wrong pen, so hold on. It's going to be 1.12, for that's going to get 20 years interest. But, so that's the first 1,000 he puts in. Now let's have a look at the second 1,000. The second 1,000 would be, 1,000. Now, it'll only go through for 19 years. But I've now also incremented it by 8%. So you can see what's happening here. The next amount, let's have a look. 1,000, would only go through for 18 years, but now I've increased it, by another 8%. So interestingly enough, I'm developing a series. So let's keep going. What happens down, ... Now plus, let's have a look at our last amount, Now we're putting it at the beginning, so at the beginning of the 20th year, so it'll be 1,000. So it's going to only get 1.12. It's only going to get interest compounding for 1 year at 12%, but the trouble is we've now putting it through for 1.08 to the power 19. So we now have an interesting scenario. We are going to now try and extract out $1,000, which we can see is a common factor, and then have a quick look at the geometric series left. Well, let's actually have a quick look at extracting. Now, before we extract, I think I'll put a times a 1 in here as well. So the first thing we're going to do is we're going to take out $1,000. Now we're going to get a 1.12, you can see here, to the 20 times 1. We're going to get now plus 1.12. 1.12 to the 19 times a 1.08 plus plus a 1.12 to the power 1 times 1.08 to the 19. You can see this is going to be a geometric series. Now, if you just have a quick look, what's happening? Well, the 1.12s are going down, and the 1.08s are coming up. So what would the common ratio be? So we need to actually divide each term by 1.12 and multiply it by 1.08. So the first thing to realize is that, what would R be? Well, R, we have to, you can see here, decrease it. So I've got to divide it by okay, 1.12. But I need to also multiply it by 1.08. Okay, so this is now my common ratio. Okay. Now, how many terms are there? Well, if you like, there's 1 to 19, or if you like, and an extra one, so it's going to be 20 terms. Okay, so there's going to be sum to 20 terms. Now, okay, sum to 20 terms. This is a geometric, okay, geometric series. And we need to work out what sum to 20 terms are of a particular, okay, what's this one is, what's the first term? The first term you can see here is 1.12 to the power 20, sorry. 20, yes, that's the first term over there. Okay, now the common ratio we just worked out was, okay, 1.08 divided by 1.12. Now, this is, remember, we have to raise this to a power 20 as well, so I'll just double bracket that, 20. Now, take off 1 using the formula, okay, and divide it now by 1.08 on 1.12 minus 1. Now, I could swap those around, okay, basically because that ratio is less than 1, but you will find that the negatives will actually sort themselves out. Okay, so what does this all work out to be when you type it into the calculator? Okay, so, and also you can see here I need to multiply that by 1,000. So when you actually do all this, you'll end up getting that the total should work out to be $139,589 and 41 cents. Okay. So I think the trick with these is to try and look at the series and then try and work out what's going on. Okay, I'm sort of like building up some of the powers and knocking down some of the powers, so I just need to sort of adjust. Or you can actually even use the common ratio term 3 over term 2 or term 2 over term 1 idea to get the common ratio. Okay, well now let's have a look at what happens when I actually do it at the end rather than the beginning. I've just drawn up the timeline again, and you can see I'm now putting it at the end of each year. Okay, so let's have a look. First $1,000, okay, is put on here, you can see at the end of year 1. Now it only has, you can see, 19 years of interest. So, and I'm not incrementing it by 8%, this first amount, okay. So it's going to, okay, increment for 19 years. Okay, so the second amount, now we haven't incremented by 8%, so, okay. Now, the second amount, obviously, okay, is only going through, as you can imagine, for 18 years, but I did increment it. Okay, all right. Now, okay, right down the end, what's happening? Okay, 19 and 20. Now, at the last $1,000, as you can imagine, will go in, basically doesn't earn any interest, but it has been incremented quite dramatically to the power of 19. Okay, so 1.08 to the power of 19. Okay, so how are we going to work out what this total is? Well, again, you can imagine it's just take out 1,000 and have a quick look at the series again. Okay, so let's actually just subtract, well, take out a common factor of 1,000 and have a quick look what's left. Okay, now let's actually now take out $1,000. So let's actually, okay, let's change that. Okay, so we're going to take out $1,000 and just see what's left. Well, okay, the first term we have is 1.12. Okay, 1.12 to the power of 19, and I'll put a 1 in here as well. Okay, plus, okay, 1.12 to the 18 times, okay, 1.08, okay, the power 1 if you like. Plus, I mean the pattern we could keep going if you wanted to write another term in here, 1.12 to the 17 times 1.08, you can see here, squared now, plus, dot, 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 plus, if you can see, let's write 1.08 to the 19, and there'll be a times a 1 there if you wanted to as well, because that last $1,000, remember, didn't get any interest. Okay, but it was incremented for the 19 years at 8%. Okay, so we now can see here that this is a geometric series again. Okay, now, again, what is R? If you have a quick look, what's happening to the 1.12s? they're going down. Okay, yes, they're going down. And the 1.08s are coming up again. So we are basically dividing each term by 1.12 and multiplying it by 1.08 like we did before. Okay. Now, how many terms are there? Well, let's have a look. The 1.08s. Let's have a look at the 1.08s, okay? Just to work out how many terms there are. Okay, so we have, you can see here 1 to 19. Oops, that 19 didn't go around too well. That 19 there. Okay, so 1 to 19 there, but we've also got a 1 here. Okay, so we have 20 terms. So again, we have sum to 20. Okay, so it's now sum to 20. Okay. Now, the only thing is now, what is the first term? Well, if you have a look, this is the first term here now. Slightly different to the one before, not much. Okay, so it's, okay, so let's actually pop that in. Okay, so it's going to be 1.12 to the power 19. Okay. Now, again, okay, if I go 1.08, okay, 1.12, I need to raise that to the power 20. Take off 1, okay. These things are going to be negative over a negative, but that's okay. 1.08 on 1.12 minus 1. Okay, it'll sort itself out. The calculator will work it all out for us. So what is the grand total? Okay, so the grand total works out to be, let's have a look, about 124,000, okay, $633.40. And whoops. 40 cents here. Okay. All right. So you can see here you actually have lost about, say, $15,000 by putting this $1,000 in at the end rather than the beginning. All right. Well, thanks for watching. Bye for now.